Okay, I wanted to review a little bit about the problem in the textbook for the Winter Glass Company product mix problem. And the question here is asking how many products should the company build? How many doors and how many windows based on the available production capacity? So they're coming out with two new products. One's a door, one's a window. And through this discussion and through more discussion, the question is how many number of units should be produced um, if the goal is to maximize the total profit. So they have the inputs here of there's three plants involved and there's two products involved, and there's a certain number of available hours per week to build these products in each of these plants. And then they also provide a unit profit number for both the doors and the windows. So what I'd like to do is walk through how do we take this input, this information, and put it into a spreadsheet. And then how do we find the answer? So again, the first three questions that we're trying to answer here can be generalized for a model or a template of future spreadsheet models that we will make. And the first question for this generalized approach is, what are the decisions to be made? What are the constraints on these decisions is the second question. And the third is, what is the overall measure of performance for these decisions? And these questions are here in the textbook. So for this particular problem, what are the decisions to be made? We want to know how many doors to produce and how many windows to produce. What are the constraints on these decisions? The constraints are the number of hours that we need to produce these in these three plants. And we're going to put these constraints in the system, in this model, right here. And what is the overall measure of performance for these decisions? The overall measure of performance is going to be total profit. We want to maximize this number. What is the number of doors and windows we should produce to maximize our total profit? So let's walk through the steps here. And here is how this data fits into the spreadsheet from the textbook perspective. But I'd like to use this table up here and put it in here. One of the nice things about this textbook is it does provide a consistent view about what the objective is, where the constraints go, and what are the decisions that we're trying to make. So if you notice, there's yellow, orange, and blue here. And these are all color-coded, which is kind of nice, especially at the beginning, to try to figure out how to help us to streamline putting this information into a model. So, like it says, we have unit profit. So we have $300 unit profit for doors. We're going to put that here in the model, which means what? That means that the company is making $300 profit per door, per unit of door, right? So each door that's made, they're making 300 bucks, which means this is probably an expensive product to make 300 bucks. Each window, the unit profit is $500. So we're going to put 500 right there. So we have our inputs here. Our profits are in. Let's look at constraints. Available per week. Let's look at hours available per week. Now, notice this is grouped by plant. So plant 1 has 4 hours available for a week. So plant 1 cannot commit more than 4 hours to make either the door or the windows. So we're going to put 4 as a limit to the number of hours that plant 1 has available. That's where we're going to put in the model, 4. Plant 2 has available 12 hours. So plant 2 has 12 hours available. Plant 3 has 18 hours available in the production. So this is basically a measure of the production capacity that is available to build these two new products. And remember, they said in the text that they discontinued some other products that were not selling very well to create space for these new products. So we've identified the hours available. Now what's left is to identify the hours used per unit produced for both the door and the window. And again, this information is provided, right? This is what the company went out and found. I think Bill was the guy who came in and helped provide this information from his group. In plant one, they would use 1 hour of time to produce each door, right? So we're going to put 1 here. And this is in units of hours, right? So we have hours available for plant one, but from a per door perspective, plant one expends or uses or allocates or takes up 1 hour of time for each door that's produced. And then they don't do anything with the windows in plant one, so that's 0. So plant one is not going to produce any windows there. Plant two is not going to produce any doors. There's 0 time used to produce each door in plant two, but it does use 2 hours to produce each window in plant two. So we'll put 2 there. Plant three uses 3 hours to produce each door. So we'll put 3 hours here. And then plant three also uses 2 hours to produce each window in their plant. And these are estimates, right? There is some possibility these are wrong. They're going to be different. They could be different as time evolves. But at this point, in terms of making a decision of how many doors and windows to produce, you have to start somewhere. Somebody in the company has given us these estimates, and we're going to take those estimates and put them into this model. So at this point, we have enough of the inputs. What we need to do is create the formulas to be able to create this model. And you'll notice here, for example, we have an hours used formula. This is cell E7 in this spreadsheet. E7 is the sum product function. And the sum product is simply saying how many hours, we're trying to figure out how many hours total are we going to use in plant one to produce doors and windows. We know we have a 4 available, and we're going to put a constraint in here that says we can't do more than 4 hours in plant one. But we need to find out what the total is used and create a formula that calculates, based on these inputs, how many hours are to be used. And what this does is it takes the number of hours per unit for both doors and windows, and it multiplies these times the number of doors produced and the number of windows produced. So for example, if I were to come in here and plug in 3, let's just assume for a second that we want to produce 3 doors. What that does is then that number comes back up to plant 1 and says, okay, you want to do 3 doors? For each of those doors in plant 1, that's going to be 3 hours. And that gives us the 3 right here. This is a 0, so it doesn't matter how many windows we produce here. It could be 4, could be 20. Because of this 0 in plant 1, that says none of these windows are going to be produced in plant 1. So we're not going to use up any hours producing them in plant 1. So we're still only going to use 3 hours here for plant 1, producing 3 doors. Okay, so this formula right here, in fact, these formulas right here, are critical to develop a model to maximize profit. Okay, now you can see that we've already gone over the limits for plant 2 and plant 3, and that's based on the number of windows. So it's probably not going to be 20 windows. Let's pull it back down to 10, and we're still over, right? So we can pull it back down to 8 windows, 7 windows. Let's just go 5. Okay, 5 gets us plant 2 constraint. We're only using 10 hours in plant 2 with a maximum of 12. That fits that constraint. But it goes over in plant 3, so we can't even do 5 windows with 3 doors. 4 windows allows us to fill each of these constraints. Does that make sense? So the hours used in each of these plants are less than or equal to the hours available. So that's kind of the manual process that we did. And again, going back to this formula, what we're doing here is we're doing the sum product of the per unit of hours for each door and window times the number of units produced. And the result is 3 here, 8 here. Why is it 8? Because 0 times 3 is 0, plus 2 times 4 is 8. And why is it 17 here? Because we're taking 3 times 3. We're making 3 doors in plant 3. Each of those doors takes 3 hours to produce. So that's 9 hours for plant 3 to produce 3 doors. We're adding that to 4 windows times 2 hours each. For each of those windows is 8, right? So that's 8 hours in plant 3 to make 4 windows. So we're doing 9 hours plus 8 hours is a total of 17 hours used in plant 3 to make 3 doors and 4 windows. And that is less than or equal to the total number of hours available, 18 for plant 3. So these formulas allow us to calculate the total number of hours used and to compare that with the total number of hours available. The last thing we need to do is this sum product for total profit. So what is our total profit? The calculation is we're going to take our unit profit, how much we make per unit, multiply it by how many units we produce for both products. So 300 times 3 is 900 plus 500 times 4 is 2,000. So our total profit, given this scenario, is $2,900. Okay, so that's how we set up. That's how we take the information from a table, from a problem, plug it into a spreadsheet, and how we can actually manually change the inputs to produce an output that aligns with our constraints and tries to maximize profit. The next step, maybe the last step that we'll do here is we're going to use Solver. So I'm going to come into my Data tab, click on Solver. If you don't have Solver here, there's a way to get it there through File, Options, and I think it's Add-ins. The textbook has some more information on that. This is the Solver window. I'm assuming most of you have seen this before. This allows us to avoid kind of the manual process that we did, trying to find out what is the doors and windows that meets these constraints. Instead, Excel can do that for us through the solver. We're going to set the objective as total profit, and we're going to maximize that total profit. This is a named range of G12, and we're going to change variable cells. These are decision cells in our model. Where in the model are we going to change to maximize that total profit? That's our units produced, and this is also a named range cell. I could click right here, click on enter, oops, and get rid of some extra language there. C12 and D12, those are the decision cells. And then finally, subject to constraints. I'm going to add a constraint if I don't have it. In this case, it's already here. I'm going to change it. What are my constraints? My constraints are I want these hours used. Notice how there's multiple cells selected here. Less than or equal to the hours available, which is also a named range. Right here. And Excel is smart enough that you can actually select more than one cell inside of these windows. So the hours used is referring to 3 cells. Less than or equal to is the constraint. We can't go over those hours. We can equal those hours, but we can't go over. And the values for those constraints are in these cells, G7 through G9. So that's our constraint. That's our only constraint in this model. It brings us back to the solver parameters window. I'm going to click on non-negative. I'm going to click on simplex method, which is LP stands for linear programming. And I'm going to click on solve. And sure enough, this is the optimal. It says solver has found a solution. We click OK, and that brings us to this. Notice that the doors is 2 and the windows is 6. So this product mix, this is the number of doors and the number of windows produced that fills these constraints. Notice the constraints are valid, right? There's no constraint that has gone over these limits. And this maximizes our total profit. So I think what was before? We had 3 and 4 here. Before our profit was 2,900. Now I can just manually type these back in, 2 and 6, and that gets a profit of 3,600. So we have pretty good. Solver allows us to do the calculations automatically behind the scenes, the mathematics behind the scenes, to identify what is that maximum total profit. And there it is. There's the answer to the Wyndor Glass Company product mix. They should build 2 doors and 6 windows to maximize their profit. I believe this is per week.